Hi everyone, this is part 2 of eliminating redundancy with the relational databases. So this should be by the time where you've had your first exposure to Microsoft Access. Access is what we call a relational database management system, meaning that it supports us creating multiple related tables with primary keys and foreign keys, as well as a whole bunch of other features that are very useful for making sure data has integrity, making sure that it's consistent and meets all those parameters for quality information that we discussed in class. So go ahead and open up Access. If you don't already have it installed, there's another instructional video for how to download and install Access from the Microsoft DreamSpark website. If you need to, pause this and follow that first to get it installed, and then open it up and get to this point. So once you're here, we want to create, let's start with a blank desktop database. They have a few different templates here with certain features already built out, but let's start with the blank one. Click on that. Now, the first thing you'll notice that's different from something like Excel is that it wants you to create the database before you even use it. So Access and other databases are different from applications like Excel, Word, PowerPoint, in that you work directly on your computer's hard drive and not in the computer's memory, or at least very little in the memory. So when we edit and work with data, many changes are often permanent because you're storing those changes directly on the hard drive, whereas with Excel, look back here at that Excel file we created in the previous video. Notice it says book 1, meaning it hasn't been saved. So where does this document currently live? It doesn't live on the hard drive. I haven't saved it yet. It's currently in my computer's RAM or memory. So if my computer were to shut off right now unexpectedly, I could lose this because the memory gets wiped and cleared out as soon as the computer shuts down. It's not until I click Save up here and save this to some location that it actually stores this document on the hard drive. So consider for a moment what that means. If two people were trying to edit this Excel document at the same time, I'm going to call this relational DB example. Save it here to my desktop. Okay, so let's say I save this file and I save it to a network drive, a shared drive that other people can access, and somebody else opens it up at the same time. If they save changes to it and then I save my own changes to it, whose changes will be saved and whose will be lost? Basically, whoever saves the file last, their changes will overwrite whoever saved it previously. And that's a problem if you're working out of a single database and you have tens of thousands of cashiers all processing transactions at the same time. So you can't have people working, databases can't exist in memory, otherwise you run into problems with people overwriting changes and you run into commitment problems. So databases exist and are created first directly on the hard drive, and every time you make a change in a database, it's immediately stored and edited on the hard drive, so nobody else can mess with it or create problems. So it wants us to create a database. Let's call this our relational database management system demo. You can call it whatever you want if you're following along. And it's going to create, it says here's where we're going to make it. If you want to change the location, click on that, but I'm just going to create this for now. Okay, in Access we have several types of objects we can create. So by default it's given us a new table or a blank table filled here, and we can create this table. And what I want to do with you, move this over to the left, move this over to the right. I want to show you how to turn this set of 4 tables we created in Excel into an Access tables, into an Access database. So we're on the Fields tab under this Tables ribbon bar because we have a table selected. However, let's click on Home and just show you a few other features. Create gives us the ability to create the different types of objects that exist in Access. Tables, which probably makes sense to you. Queries, which you'll learn in a couple of days, a couple class days. That's a way to remember those questions I asked over here. How many baseballs did Homer order? It's a way to write questions like that can be automatically answered by producing or generating data from the tables. Then we have the ability to create forms. We're not really going to get into forms, and then also reports in this class simply because we don't have time. But once you have a good Access database set up, you can have a form gives you the ability, a nice, pretty interface to enter in data so that you can share this database with people who aren't database managers or who don't understand the workings of the database. And then reports are as simple, like they sound. It's a way to summarize data out of the database for managers for decision making. But let's just worry about tables for now. So this first table, let's replicate our customers table right here. So the view we have right now is meant to look like somewhat like what we have in Access. Click on the Home tab, and the first thing I want you to learn about are the different types of view options. So currently we have the data sheet view, which is a lot like this Excel view over here, or the design view. Now when it comes to creating a table, although you can create it in either view, the design view gives you a whole lot more options. So before I can switch to the design view, notice it says we want you to save this table and give it a name. So currently table 1 does exist in memory. It hasn't been committed to the hard drive yet, which is not a problem because we can't enter data in it anyway. But there are a few examples like this where some of the changes we make in Access do live in memory until they're saved. So let's give this one a name. We'll call it Customers. Okay, now this view, imagine taking this Excel spreadsheet and flipping it sideways so that instead of F name, L name, and account name appearing across the columns, now they appear down the rows. That's what we're looking at over here. So the first one, let's actually make this first field account number. I'm going to call it num like that. Next thing I have here is the ability to give it a certain type, specify the data type. Remember when I said in the previous video that integers or numbers are stored differently than text? So that has to do with the number of bits required to store a number. So if I'm going to store a number in a particular digit or in a particular character field, there are only 10 options, right? 0 through 9 that it could possibly be. So when it comes to deciding how many bits are required to store 9 different numbers, you only need 4 bits to store 9 numbers. Now with text, there's 95 possible characters. There's uppercase, lowercase, numbers, variety of weird keyboard characters. It takes 8 bits to store a potential piece of text. So if a certain field is only ever going to have digits in it, then we want to create it as a number field, or possibly a currency or an auto number, and that will take up much less room and make our database much faster. So an auto number, the only difference between a number and an auto number is that with an auto number we don't actually have to enter that number in, and that's useful for things like account numbers or primary keys basically. So I'm going to leave that as an auto number, and let's now enter in F name. And if you look at our data types, short text, as you can see here, let's select short text for now. Look down here in these field properties. Field size means that this field can have up to 255 characters in it. So short text is plenty long. If we were to change that to long text, notice that's gone, and it means that we can enter basically as much data as we want. Well, for all intents and purposes at least. So I'm going to change this back to a short text, but we really don't even need 255 characters. In fact, we can say, hey, we can't imagine anyone having more than 15 characters in their first name, so we're going to change field size to 15 and save ourselves some space. There are various other properties here. Format, you can specify that anytime enters a first name, the first character is automatically capitalized, the rest of them are lowercase. Default value, if someone doesn't enter in a first name, you can say simply enter the text F name or leave it blank. That would be open and close quotes. I'm not going to go through all of these, but know that this is the way we can help ensure some of the integrity of our data. We can make sure that only integers or only numbers are entered into price fields. We can make sure that there are no spaces allowed in a name or something like that, although that probably wouldn't make sense because some names can have spaces. But anyway, here's how we ensure the validity of the data. It's a nice characteristic of a database management system that Excel, well, you could program into Excel, but it's made much easier by a true DBMS. So I'm going to leave fname like that. All name, short text. Notice we can also have this required field here. Would we want to make at least one name required? Well, that's really it's an issue, a management decision. Technically, we can make any requirements we want. I'm going to set it to where last names have to be entered. In other words, you can't even create a new row and save it to the database, save it to the hard drive if a last name hasn't been entered. Notice up here, there's this little key symbol next to the account num field. And notice down here, there we go. We don't have that required option because it's going to assume if you made this a primary key, it must be required. So let's leave this table as is, and let's switch this back to the datasheet view. Now at this point, it's going to want to save it again because we've changed the structure of the table. There's two ways to change a table. You can either change the data in it, which in that case, that data is saved automatically to the hard drive, or you can change the structure of the table, meaning you're changing the columns, or you're changing some of the validation requirements or the data type. Those are changes that happen in memory, and then when you switch to the datasheet view, you have to say yes, save it before it's committed to the hard drive. Okay, so now let's enter some data in. Notice I get this little new text here. That's because there's no data here. And anytime you go to the very last row in a table, it's going to assume that's where you're going to enter new data. So because I set account to be an auto number, I don't have to enter a number in that field. I can just come over here and start typing Homer Simpson, and notice it automatically, it looks at all records in the table, finds the highest number in this field, and then adds 1 to it and makes that your new account number, which is pretty useful if you're choosing some arbitrary number as your primary key. All right, so Marge Simpson, let's just do the same thing again. Oops. It found 1 as the highest number in the account number field and added 1 to it and then made Marge number 2. All right, so there's our customers table. I'm going to leave this one now and create a new table. So I'm going to close that one out, create table, and now I want to switch over to design view. It says, what do you want to name it first? Let's call it orders. Okay. And instead of calling this ID, I'm going to call it order ID. Leave it as auto number. That's no problem. We'll do that. And let's see, we have order date. Actually, we know it's orders table, so I'm just going to call it date. Oh, it says it. Let me show you exactly that error was. The name you supplied is a reserved word. Reserved words have specific meaning to Access or to the Access database engine. If you use a reserved word, you may receive an error when referring to this field. So certain terms like date, there are a variety of them, are words that have some meaning to Access. And if you call a field by date, well, the programmers who write programs to access that field may run into some problems. So you probably wouldn't run into any problems, but to make it easier on your programmers or other people who are using this database, it's often good to not use reserved order. So I'm going to go back to order date. Okay, data type. Now a date is stored smaller than a text, but it's larger than a number. So we have a special date time data type for that. Order, let's call this one total. Now in reality, we probably, well, there may be reasons to store a total field, but in this case, we could calculate order total from the sum of the ordered line items. So sometimes it makes more sense just to not even store total, since you can calculate that in other ways, but I'm going to leave it in for this example. In this case, Access has a special data type called currency, which is larger than a normal number. Well, without getting into the details, we'll just assume that we want to use currency for anything that's currency. Okay. So I'm going to leave account number. Well, no, I better go ahead and put it in. And in the other field, we called it, let's see, account num. And I'm going to use those numbers that were automatically created, but set this to be a number. And in this case, required must be yes. We don't want to enter a field. This is what's called an integrity constraint. We don't want to have any orders created unless it's tied to a customer's account number. So I'm going to say that required equals yes here. Although our numbers aren't very big, so I can change that to what's called an integer, which is a smaller number. Okay, that is good for now. Let's save that, flip back to the datasheet view. Yep, save the table. Let's enter our data in. So notice, because it knows total is a currency and order is a date, it gives us some extra help. It gives us a little date picker here. I'm just going to select, there we go, a date. Total for this first order was $50. Account number is 1. Whoops. Extra key on accident. Okay. Next order, we'll say happened the following day. This total was 100, account number 2. Now, even though we didn't create other orders over here, I want to add a couple more in. So let's say that Homer came back also the following day and decided he needed something else. His total was $10. That's account number 1 again, because 1 belongs to Homer. Okay, and maybe I'll make one more for Marge too. $40. Notice how even though I just typed 40, it automatically reformats it for me. Made that Marge. Okay, so when does this data get stored to the hard drive? Basically, if I type in the number 1 or 2, how about instead, let's change this to $50. The second I hit my arrow up or down, that change has already been stored to the hard drive. It's permanent. With some exception, you can undo just the last record you changed, but you can't undo more than one. That's just, again, to make sure that all changes are are stored and permanent, and that you don't run into read-write problems with other people accessing the same database. The purpose of a database is to allow shared access to data. So just count on it. Other people are going to need to use it. Anyway, I think you kind of get the idea now. Let's go ahead and create our last two tables. New, or create table. Switch to design view. We'll call this one order line items. Okay, we'll call this line ID. Auto number is good. We'll call this quantity. It's going to be a number. Order. Did we call it order ID or order number? I can't remember now. Let's see here. Order ID, okay. Order ID, oops. And this is going to be a number, and it's going to be required. Required equals yes. And it probably won't need to be anything more than an integer, not a long integer. Okay. And then we need to tie order line item to both the order number. Notice how we have two foreign keys. The order it came from, as well as the product that's on that line. So order number, let's see, prod ID, also a number. We're going to make that also an integer and make it required. Okay, that should do it. Let's go back to design view now, right here. Notice how I can hit the down arrow and select design view, or if I just hit the icon above it, it'll automatically flip back and forth between the last view you were looking at. Yes, save the table. Okay, let's enter the data in for these. The first order, quantity 1, order ID 1, product ID 1. Next one, quantity 2, order 1, product ID 2. Next one is quantity 1, order 2, product 3, quantity 3, order 2, product 2, quantity 1, order ID 2, product 1. But then remember, I created 2 more orders. So I'm just going to, I'll come back and add that data in just a moment. So for now, this matches what we have right here, except I've gone back to using these foreign keys, or these primary keys that I had originally, because they're the ones that were automatically generated in Access. Okay, last table. Create table, design view, call it products, product ID, auto number is good, name. Okay, here's another reserved word, name. So let's go ahead and change that to product name. Okay, notice I'm not using any spaces in the field names. Technically, Access these days can allow spaces in the field name, but it's common convention to not use that. It'll make it easier on your programmers or other people who might access this database. So my suggestion is to always create field names without spaces or alternative characters. Okay, short text, that should be sufficient. 255 characters, we'll say that's enough. And price. And this is going to be currency. Okay, let's switch back to datasheet view. Yep, we want to save it. First product name we have is a football, $30. Baseball, $10. And basketball, $40. Okay, that's it for our product table. So I added a couple of orders for Marge and Homer. Let's go ahead and, here's our orders table, numbers 3 and 4. Let's add some light items to come up with a cost of $10 and $50. Let's say that Homer, for order 4, we're going to come over here and say, okay, for a new order, number 4, he purchased one, well, what product would cost $10? Well, that's our baseball. So baseball's product ID 2. So back here in order line items, let's call that product ID 2. Now, if I didn't put that in, I try to change lines, what does it say? You must enter a value in the order line items table, dot, so it always gives you the table name, dot, field name. You've got to have that. Remember, we made that rule. We can't create a new row without the product ID or the order ID. Okay, no problem. So come back here and put that back in, and it should do the same thing on this field. If I delete the 4, try and move, yep, same problem. Okay, so our other order we created was order 4. Oh, excuse me, did I make that one 3 or 4? No, this one should be number 3, my mistake. 3 is the one that was $10. There we go. So order 4 is 50. What products do we have that we can make that comes up to 50? Let's make it 1 baseball and 1 basketball. So back here under order line items, we want to say that order 4 has a baseball, which was number 1, and is product ID 2, as well as a basketball on order 4, 1 basketball, order 4, product ID 3. Notice how this is kind of a pain to have to go through and match up the numbers with each table and come back here and enter them in. There are better ways to do this so that we don't have to go and look up each of the numbers, each of the primary keys, and enter them as foreign keys in other tables. At this point, this is probably a decent place to stop. We're going to learn next how to use what's called, up here in the database tools, the relationships diagram. And this is going to allow us to tie these different tables together so that we don't have to remember these foreign keys, primary keys, and make life a lot easier on us. So let's stop this for now. And at this point, you've had a good exposure to Access and how it works, at least the process of creating tables. Next, you need to learn entity relationship diagrams. And once you learn that, you'll be able to come back and watch the next Access video that will cover the relationships diagram, and then we'll move on to queries.